In this class we are going to discuss about the next concept, that is ring counter. Okay, so that means the counter will count in the clock pulses in the form of the ring shape. Okay, so we are counting the number of clock pulses here. So how many clock pulses will required for this transition of the flip-flops? So then that will be counted in the sequence format. Okay, so that is called as the ring counter. So this ring counter is also known as the circular shift register. Another name we are having for this circular shift register also. Okay, so this is the circuit diagram for the ring counter. So here also we are taking the 4-bit shift register. That's why we are representing 4 flip-flops, and only one clock signal is connected to all the flip-flops. So this will be called as the synchronous counter, because there is no negative transition, and here will require there is no bubble with clock. Okay, there is no clock having the bubble. So that's why we can say that this is a synchronous counters. Okay, so see here, it is used to control the sequence of operation. Okay, so it is used for controlling the sequence of operation. And in this counter, output of each stage, so output of each stage will be connected to the input of the next stage. See here, so the first flip-flop of output is connected to the input of second one. Like that, second one of output is connected to third one of input, and third one of output is connected to the fourth one of input. So that means the output of the last flip-flop. So see here, the output of the last flip-flop will be again connected back to the input of first flip-flop. That means what is the logic behind in that ring counter? So for each and every flip-flop of output is connected to the next flip-flop of the input. So as well as the last flip-flop of output is connected to the first flip-flop of input. Okay, so this is the circuit diagram of the 4-bit ring counter. Okay, so now we'll see the here circuit operation. So now we'll see working principle. Initially, so at the first position, so all the flip-flops will be reset. That means it will be zeros. That means we don't know the exact output for it initially. So initially we cannot apply any clock signal now. So that's why we didn't get any results. So we can say that the output will be 0. So here I am representing the value will be like this: Q4, the outputs Q3, Q2, Q1. Okay, so whenever the clock is 0, so then at a time all the flip-flops will be in inactive position. So we'll get the output will be reset, that is 0. So whenever the clock transition will be takes, so this will be in high position. So automatically flip-flops will be get activated. So in that case, whatever the last flip-flop we are having, so that output is connected to the input of first, no. So from here we have to give the serial input. Actually input we are giving here, no, and output we are collecting here. Okay, but here whatever the Q4 output we are having, that will be given as to the input. So for that case, you have to remember, at initially at given point of time, only one flip-flop is set, otherwise remaining flip-flops will be reset. So only the one flip-flop is set, I can choose it as Q4 is the set. So set will be represented by what? 1, and reset will be represented by zeros in binary. So that's why I can represent it here. Q4 value will be only set, and the remaining all the flip-flops will be cleared here. Okay, so then I can choose it as at initially. What is the value we are representing? Initially Q4 only set, and the remaining all the flip-flops will be zeros. So that means you can represent the information here. At initially, at a given point of time, Q4 only set, and the remaining all the flip-flops outputs will be zeros. Why I am taking Q4 only set means here, for the first Q4 output is connected to the input to the D flip-flop. That's why this output only we are choosing 1, and the remaining flip-flops output will be zeros. So now what happened? This output will be given as to the input of first one. So this one will be present to the D flip-flop. So what is the main function of data flip-flop? So whichever the data flip-flop we are taking, whichever the D flip-flop we are taking, so what is the main function for that means, it can be directly whatever the input we are giving, that will be as it is present at the output side. So whatever the input we are giving for the D flip-flop, as it is, that will be present at the output side. So that means here we are giving the 1 now, so that 1 will be present at the Q1 output. So coming to second flip-flop of output, what is the result of D flip-flop means? Here we are giving the output of, so Q1 output we are giving to the D input, right? So that means this one will be given to the D flip-flop, but here the shift right operation will be placed. So then what happened means, whatever the previous output we are having for this Q1, previous means before the stage. So before the stage means this is the result, right? So this result will be present at the Q2 output. So that means 0 we are getting. Like that, third stage of Q3 output means again it will be depends upon the past output of the Q2. So past means this one. So 0. So next, like that, Q4 result is nothing but past output of Q3. So shift right operation we knows, no? So here also clock will be high. So then what happens means the first flip-flop. Okay. So the first flip-flop output we are getting as 1. Okay. And the remaining Q2, Q3, Q4 outputs will be zeros. Because this one will be given as input to the Q1 stage. Okay. So here this one will be given as input to the Q1 stage. That's why the Q1 will be directly saving the data as it is 1. So remaining flip-flops means the previous data whatever we are having here, Q1 of previous data that will be present at Q2, and Q2 of previous data that will be present in Q3, and Q3 of previous data that will be present in Q4. Previous data means this one. Okay. So in the next clock pulse. Okay, next clock pulse we are applying at time t2. So then what happens means here again, so what is the fourth Q4 data we are having? 0, no? So that 0 will be here present. Okay, so like this we are getting the data is again previous data we are getting. So here whatever the previous output we are having in Q4, what is the result we are getting in previous second clock pulse? So that is nothing but 0, no? So this 0 will be presented as this Q1 stage, because this 0 will be given as input to the D flip-flop. Okay. So now D flip-flop as it is, this bit can store, no, in the first stage. So what about the second stage of output? This previous bit. Previous bit is nothing but this one. Okay. So the one is placed here and this is the previous. So that is 0 and for this previous is 0. So like that we are getting. Okay. So here the first one is 0 and the remaining will be 1 0 0. So previous data will be shifted like this at time t3. So then what happened again, the Q4 bit is given as input of Q1. So the 0 will be present here and the previous bit 0 1 0. Like that at T4 time clock pulse. Why we are taking 4 stages here? So we have 4 shift registers, no? That's why we are taking 4 clock pulses. Okay, again the Q4 bit is given as input to the Q1, that will be as it is stored. So then remaining will be previous bits can stored. So see here at initially we are giving the data as 1000 for the all the flip-flops of outputs. So after reaching the 4 clock pulses, again we have getting the same data. See 1000 1000. Okay, so the counting sequence continues till the counter counts 1000 at 4th clock pulse. So this counting sequence of the ring counter is like this. Okay, so this is the explanation about ring counter. So remember that one. So at initially all the flip-flops will be reset whenever the clock is 0. Okay, so that's why all the outputs of the clocks will be zeros here. And coming to the whenever the clock is activated, so at initially all the flip-flops will be reset except one flip-flop. So that means only the one flip-flop will be set and the remaining flip-flops will be reset. So that set flip-flop I can choose it as 4th flip-flop, because here the 4th will be given as input of first one. So we need this one only, because from this only the input is given. That's why I can choose it as 4th one will be considered as 1 and the remaining will be considered as zeros. So 4th one Q4 will be considered as 1 and the remaining will be 000. So ring counter is nothing but it is a circular, right? So that means again it will be reached the starting position. Okay, so where it will be started and it will be ended with again the same position. So that means 1000 we are started, The data will be sequence started with 1000. Again it will be ended with the 1000 only. Okay, so like this we are getting. So 0001 first one, and the next one is 0010, and the third one is 0100, and the next one is 1000. Okay, so after 1000, if you want to shift again, so if you are having more shift register, again you have to repeat the procedure. Okay, so like that we are getting the ring counter procedure. So after completion of ring counter, then we'll go with the next counter, that is Johnson counter. These both will be important for short answer. So remember that one. So Johnson counter is nothing but here we are taking the 4-bit shift register here also. That means we have to connect the 4 flip-flops, that to D flip-flop we are choosing. Okay, so what is the main function of D flip-flop? Whatever the input we are giving for the D flip-flop, that will be as it is can stored in the output side also. Okay, so this is the D flip-flop main function. Here we'll see the circuit explanation. So see, the output of each flip-flop is connected to the input of next flip-flop. Right, so see, the first flip-flop output is connected to the input of second one, and second one of output is connected to third one of input, and third one of output is connected to the fourth one of input, and here fourth one of complement output is directly connected to the input of first flip-flop. So see here, observe the difference. In ring counter, normal output of last flip-flop is directly connected to the D flip-flop of first one input, right? So but here complement of the last flip-flop is connected to the input of first one. That is the difference we are having in between Johnson counter and ring counter. And also the clock will be all the flip-flops should be connected as single clock, so that it runs with the similarly. Okay, all clock pulses will be runs with similarly. Okay, so now we'll see this circuit operation. We know here normal clock pulse will be applied to the ring counter. At initially we set it as one flip-flop will be set, right? So remaining all will be reset, but here we are not taking like that. So how to take that clock pulses means I will show that. So clock, here you can represent the outputs, that is nothing but Q0, Q1, Q2, Q3. So now we'll see the circuit operation here. Here observe the thing, at initially whenever the clock is 0, all the flip-flops outputs will be what? Zeros, because the clock is inactive position, no? So that's why all the flip-flops outputs will be 0. Okay, so you can represent it here. Q0 is equals to A, Q1 is B, Q2 is C, Q3 is D. Okay, A, B, C, D I am sure already I presented, no? So as it is I can represent it whenever the clock is high. Okay, so what is the result of this Q0, Q1, Q2, Q3 means here how to give the input for this D0? It initially serial input will be given from the where? Q3 complement, right? So already we know the Q3 value at initially, that is 0. So then automatically Q3 complement is what? For 0, it may get it as 1. So from this we can consider because Q3 value already knows 0. So Q3 complement we are getting, that is 1. So this one will be given as input to the first flip-flop. Okay, so now I am giving D0 value will be 1. So then what happens in the first flip-flop? Already we know the serial input. So whatever the input we are giving to the first flip-flop of D, then it will be storing as it is. So Q0 value will be 1. And what about the remaining flip-flops outputs means whatever the previous outputs we are having for this Q0, Q1, Q2, Q3, that will be shifted to the next level. So previous bits means like this. So the 0 will be shifted here, this 0 will be shifted here, 0 will be shifted here. Like this, taking the second clock pulse. So what happened again? The Q3 complement result is given. So what is the first stage of Q3 complement result? Q3 value will be, we are getting, here we are taking only normal values So Q3 we are getting 0. Okay. So Q3 complement again what happened? complement we are getting. So that means 1. So 1 again we have to apply it here. So that means again this 1 will be stored in Q0 place. So 1 will be placed here again because this complement we are taking. Okay, so again it will be shifted to the previous outputs. Again apply the next clock pulse. Q3 value will be complement. Okay, so Q3 complement value means again here Q3 value will be 0 now. Complement we are taking 1. So the remaining will be previous bits should be placed. Here what is the value? Q3 value 0. So 0 complement we should take it 1. So 1, it's 1 and here 1. Okay, so this is the 4 clock pulses represented. Okay, so after 4 clock pulses, so again what is the last data we are getting Q3 output? That is 1. 1 complement we are taking here, right? Because it will be connected to the complement path. So 0. Again 1, 1, 1. Okay, so for this again you have to take it complement 0. So for this 0, for this 1, for this 1. So 1 complement means again 0, 0, 0, here 1. Okay, so now finally this 1 complement is nothing but 0. So 0, 0, 0. So that means initially whatever the result we are taking, so after reaching how many clock pulses? 3, 6, 7, 8. So after completing the 8 clock pulses, again the data will be moved to the first place. Okay, so this Johnson counter here we are taking the main part is the output of last, that means Q complement output of the last stage is connected to the D input of the first stage. That's why we are taking all the values of the complement will be taken as Q0 value of first stage. Okay, so then after reaching 8 clock pulses, then again we have to show the same digit 0000. Okay, so this is the explanation about the Johnson counter. Okay, so please concentrate on this truth table of Johnson counter and ring counter. Both will be important for short answers, ma. Okay, so be careful and observe the circuit diagrams. Johnson counter is complement output is connected to the input of first one, and ring counter is normal output is directly connected to the input of first one. That is the difference we are having in between these two. Okay, so this is the complete explanation about the 4th unit.